All right, so the first two examples, the example I did, plus the example you did, I gave you the bounds, correct?
Yeah.
So now you're not going to get the bounds, and I'm just going to say, hey, we need to go ahead and integrate in between these two curves. So we're going to have something like, let's see, y equals x plus 3, and y equals negative x squared. Nope, we did that yesterday. Wrong line. We did that yesterday. We have something like this. F of x equals 2 minus x squared. And g of x equals x. And they want you to integrate the enclosed region. So whatever's enclosed for where these guys intersect, they want you to integrate that. So what I'm going to do is I'm going to graph these. Just give me a rough sketch to give me an idea. So right off the bat, we are going to graph it. I know the negative x squared means my parabola is flipped upside down. And then this is a positive 2, so it's moved up 2 units. So this would be 2 right here. And then it's coming down like so. So that would be the f of x. Now don't get in this notion of this is going to be my f of x when I do the f of x minus g of x. We have to look at top curve minus the bottom curve, right? And then the next one is just x, y equals x. Well, that is right here. It's 45 degrees coming out of the origin. So we're talking about the area here. So I have to find my bounds. So what am I going to do to find my bounds? Algebra. And then we're going to find the intersects. How do we find the intersects? Set them equal to each other.
Yeah.
So we have 2 minus x squared equals x. All right, y'all tell me, what's my step? So you have positives. 0 equals x squared plus x minus 2. Okay, now what? We can factor. What does this factor to? Perfect. All right, somebody else besides Chandler, what's our next step? Set them equal to 0. What's that called? Zero product property. So x plus 2 equals 0. X minus 1 equals 0. And you should clearly see that x is going to be negative 2 and x is 1. So we have our bounds of integration. All right. Now we have to make sure that we're doing it correctly. F of x minus g of x. My top curve minus my bottom curve. Which one is my top curve? Is it f or g? F. All right. So then we're just going to integrate from negative 2 to 1 of 2 minus x squared minus x. I put the parentheses because it's the whole thing. So I remember that if there's more than 1, I have to distribute the negative sign. And then dx. So I'm integrating from negative 2 to 1 of, I'm going to pull a negative out front. Okay? Because I don't like all those negatives. X squared plus x minus 2 dx. And then from there, it's just working your elbows, isn't it? Yeah, just working your elbows. So we got a negative, boom, there. You know, I'm not going to find this. Y'all already know how to do it. Y'all find it for me. Y'all find it for me. I'm going to go ahead and say this is on the non-calculated portion of the AP test. This is on the non-calculated portion of the AP test. Okay. You straightened away. All right, let's do another one. Yay, yay. Okay. F of x equals sine of x, g of x equals cosine of x. And my bounds, I want it between 0 and 2 pi. So those are not my bounds of integration. I'm just telling you, hey, we're only going to do one revolution of the unit circle. We're only doing one period of each wave. So we still have to do the same thing. We have to find where they intersect. So once again, graph. We only have 5 minutes, so we're going to set this up so you can see your bounds of integration. Then it's the same process. All right. So sine, right? Cosine. So we need to find here and here. We were looking for this area, the area of this region. But we need to, of course, then find these points. So then what do? Set them equal. All right, let's put this as F, this is G. Set them equal. I've got sine x equals cosine x. And where it's going to be between 0 and 2 pi. All right, guys, how would you solve this one? You could think it if you know the unit circle. Where does this occur at? You could think it if you know the unit circle. Where are the x and y values the same? All right, so you're not quite sure yet. 1 and 4. No, 1 and 4?
Oh, no.
They have to be exactly the same.
Oh, yes.
So 1 and... Where do they have the same signs? 1 and...
5. Oh, yeah. The quadrants?
Yeah.
Oh, yeah.
1 and 4 have the same x and y signs?
Yeah.
Positive x, positive y?
Yes.
And 4?
And 3.
3. Quadrant 1 is positive, positive. Quadrant 3 is negative, negative. So if you know the unit circle, you should be able to think this through pretty quick. And then when do they equal? They're the same thing. At what two angles?
45.
In radians. This gave it too many radians.
4.
So pi over 4 and
5 over 4. Yeah.
Bam, there's your bounds. If you're thinking that way. If you want to solve it, the best way to do this, divide everything by cosine. Sine over cosine is tangent x equals 1. Cosine over cosine is 1.
Oh, yeah, and then you just arctan.
You take arctan. So arctan, it only occurs in one spot.
Whoa. What is that? We don't do that.
Arctan of 1. That answer, you're only going to get one answer. It only gives you one answer, but then you have to remember there's that second answer out there. Because it's the same, tangent is the same, it's slope, so it's going to have the same slope from quadrant 1 down to quadrant 3. So you have to realize in quadrant 3, if you remember the formula, it's 100, it's not 180, it's pi. Yeah, you remember these things? You have to do pi plus your reference angle, which your reference angle is pi over 4, which gives you 5 pi over 4. If you know the unit circle, that's why I had y'all memorize it last year, right? If you know the unit circle, you should be able to do that just from this, from the original equation. Thinking it through. Then once you have your bounds, it's the same thing, isn't it? Integrate from pi over 4 to 5 pi over 4. What's my top? Follow it. What's my top? Sine. Minus. And then from there, it's just the integration game again. All right, guys, you got 1 minute. Good job today.
Can I close down the AB test?